All right, hi seventh graders. Today we are working on 9-7. We're looking at polygons. You need your hardcover book open to page 252, 253. I've got mine over on my side so that way you guys can look at my notes. You should have yours open on your side and maybe have your notes out as well, unless you just love coming back to my videos and refreshing, which that's okay too. So, we are starting with polygons today. Remember, hit pause if you need to catch up on your notes. That's what the beauty of video is. Also, the beauty of video is this is my third time teaching the lesson because I keep making mistakes. So, look at that. We're both learning. Okay, now, when we talk about polygons, the whole reason that Miss Underhill and I have worked with a week and a half on all these other vocabulary words and doing review of the vocabulary and going over and over and over again, it is because everything spirals together and we're putting it all together. So as we go through this lesson, you're going to have some vocab words that trigger your what you remember, and you're going to go, oh, it's all coming back. Here's a little Celine Dion for you. It's all coming back, it's all coming back to me now. All those vocab words, I keep singing for you later, don't you worry. In the Zoom, I'll sing the whole song. But that's what's happening is all these vocabulary words are going to come back to you and you're going to say, oh, I know what that means. I know what that means. And it's going to be building off of what we already learned. Okay? So polygons are a closed plane figure that has 3 or more sides. So the main thing I want to show, closed. So notice how this is a closed object. Right here, this is left open, not a polygon. Okay? Let me make sure I can see it in the video. Sometimes I've been writing over here and nobody can see it. So a closed plane figure means that they all have to close with 3 or more sides. So that's important to note too. 3 or more sides. Now, each side is a line segment. Okay, and on my other one I had it all set up. Sorry guys. Each line is a line segment. So if this is my polygon, A, B, C, D, E. Line segment AB, line segment BC, line segment CD, line segment DE, line segment EA. Okay, so each line is a line segment. Okay, the line segments meet only at their end points. So the line segments meet only at their end points. What's another word for those end points? Vertices, also known as vertex. Vertices is the plural version of it. So A is a vertice, B is a vertice, C is a vertice, D is a vertice, E is a vertice, right? Now, the interior angles. Polygons have, I'm on page 252, I'm reading from the book, moving to my notes. Polygons have both interior and exterior angles. Interior angles lie inside a polygon. Here are our interior angles. They lie inside a polygon, okay? The number of interior angles is the same as the number of vertices. So, angle, vertice, angle, vertice, angle, vertice, angle, vertice, angle, vertice. You are going to see that on the homework, and it's going to be almost so easy where you're like, no, this is wrong. No, it's not. The number of vertices is the number of angles. Isn't that beautiful? So let's write that. Number of vertices equal number of angles. That one's important. Okay, now the exterior angles. What you can do with an exterior angle, the sides of a polygon can be extended to form an exterior angle. I can extend all of them to form an exterior angle. Angles that are outside, right? I can form that one too, okay? And they can go both ways. So, when I form that exterior angle, each exterior angle is adjacent. Oh, it's all coming back, it's all coming, right? Adjacent. So angle right here and then the angle right here, they're pushed right up next to each other. They're adjacent. Let me write that one down. I will not choose this color again because it's too light. Adjacent and my fancy and sign. Supplementary. Uh-oh, I'm going to sing again after I write this because I can't multitask well. All coming back, supplementary angle, that's 180 degrees. Oh nice. I remember. Okay, so angle C plus this exterior angle equals 180 degrees. So if this is x, what we could do is do 180 minus x, and that will give us this exterior angle. All right, so we're going to work on how to find x too. That's all today. All right, so as we keep moving, I've got my next page. There are two types of polygons: convex polygons and concave. Sorry, my computer just made that noise. Oh, okay. A convex polygon, in the interior angle of a convex polygon, it measures less than 180 degrees. So here's my convex polygon. Okay, sorry this is a little bit sloppy, but so each interior angle is less than 180 degrees. What's 180 degrees again? Oh, that is, let me use my black marker. That is a straight angle, remember? So 180 degrees is a straight line. So on a convex angle, or a convex polygon, all of the angles inside are less than 180 degrees, right? They're more than 90, but that's not something I'm worried about right now, because a straight angle is 180 degrees, so they're less than a straight line. Okay, now, this is where it's all coming back. I'm so excited about this one. A concave. Oh, no, I got too excited. Don't look at my bad spelling. Okay, a concave polygon. Let's just say, thank God for whiteout. That's what saves me. A concave polygon, one or more of the interior angles has a measure of greater than 180 degrees. What is that angle called? It's a reflex angle. Look at that. I haven't gotten to use this note card in a while, so it's pretty sticky. But that's an angle that's greater than 180 degrees. Take a look right there. Bigger than 180 degrees. Bigger than 180 degrees. Remember, because my 180 degrees would be my straight line. Straight line. Okay? So, concave means that it has one or more interior angle that has a measure greater than 180 degrees. Concave are the ones that have something coming inside, right? It's a cave. There's a, yeah, I'm just going with cave. Okay, convex polygon are our normal ones. Okay, so as we keep moving on, a regular polygon, I'm on 252. A regular polygon has congruent sides. Oh, it's all coming back. I know what congruent is. Equal to. So all the sides, a regular polygon has congruent sides and, sorry, I've got to switch colors. That's just like my thing. Congruent sides and congruent angles. Okay, so look right here. In this square, all my angles are congruent. They're all equal, and all my sides are congruent. Okay? In this polygon, in this quad, well, no, not quad. Oh, what is it? Pentagon, because there's 5. You know what? I actually went to the Pentagon in Washington, D.C. Just took me a second. In the Pentagon, there's 5 sides, all equal in a regular polygon, and all of the angles are the same. They are all equal. Oh, we should go on a Washington, D.C. trip. I promise, I would be such a fun chaperone. Oh, I'd probably go to sleep too early, though. Okay, the next one. We're talking about triangles. Remember, if I can bring you back to page 1, 3 or more sides. So a triangle counts as a polygon because it has 3 sides. It's the smallest one. A triangle is a polygon with 3 sides and 3 vertices. Okay, so let me use a fun color. 3 sides, 3 vertices. Okay, now the sum of the interior angles of a triangle will always equal. So when you add up all of the interior angles of a triangle, it will always equal 180 degrees. Miss Underhill talked about that on our last worksheet with all the X's and stuff, but now we've got it in our textbook, so we are going to be pros on this. All right, now I'm moving to the next page. All right, you can find the sum of any polygon's interior angle measures by dividing the polygon into triangles. So they're going to give you this long, elaborate, thing. I'm going to show it to you. Hear me out and then listen to what I have to say. All right, so what they want you to do is they want you to draw the diagonals. So I can't draw to this angle, but I'll draw here and here. I'm connecting from this vertex. So I created 1, 2, 3 triangles. Okay, so draw diagonals, the number of triangles. Then count the number of triangles. Well, that's 3. Then multiply the number of triangles by 180 because remember, triangles, angles all equal 180. So what I would do is 3 times 180 to find out what this pentagon, 1, 2, 3, 4, 5-sided figure is. And hello, calculator. Always be my friend, never leave me, except for my phone was dead earlier. 3 times 180 equals 540 degrees. So this pentagon, the interior angle, the sum, when I add them all up, is equal to 540. So here's what you can do without the diagonals. All right, so here, remember I said, hold on. All right, you're going to count the number of vertices. 1, 2, 3, 4, 5. So I have 5 vertices. Then I'm going to subtract it by 2. Okay, that's just, I have to do it. So 5 minus 2 gives me 3. 3 times 180, we would do it the same exact way. Okay, so you've got 2 ways of doing it. Draw your diagonals or count your vertices and subtract 2 from it. You're always going to be subtracting 2. Okay, so that's how you find the sum of all the polygons. Every single angle added up is going to equal 540. But how do I find the measure of just one polygon? All right, how to find the measure of one polygon? I said I wasn't going to use that blue anymore. Let's use another fun blue. All right, so what I would need to do is, say I'm working with my pentagon again. Remember, a penta means 5, and then we got the gon, meaning it's a closed figure that has 3 or more sides. Yes. Okay, so now I'm going to put 5. N is my number of sides, my number of vertices. Remember, sides and vertices are congruent. So I've got 5 minus 2. This is to find me one interior angle. 5 minus 2 times by 180 divided by 5. Now this is only if it is a regular polygon, saying that each angle is equal. Now, we'll be able to figure it out because we have all of our tools, we have all of our knowledge with supplementary angles and all of that other stuff to figure out if it is a non-regular polygon. Okay, so here we go. Hi, calculator. PEMDAS says I have to do what's in parentheses first. So 5 minus 2, hit equal, because remember, PEMDAS, the calculator follows PEMDAS, so we need to do equals. Then we hit times 180, okay, 3 times 180. Then we would divide it by 5, and I would find out what one angle in that polygon is 108 degrees. Now, if I wanted to find out and make sure that it's correct, I know, where is it? I know that all 5 angles added up together is 540. So if I were to plug this back in, 180 plus 180 plus 180 plus 180. I bet you're rolling your eyes and saying, Miss Washburn, why didn't you just click times 5? I just want to prove a point. 1, 2, 3, 4, 5. They add all up to equal 540. I wish that my calculator would be a different color so it's easier to see in the videos. But how to find one angle? We take the number of vertices, the number of angles, and we would subtract 2, times it by 180, and then divide it by that same number, okay? To find all of the angles, we're going to do the number of vertices minus 2 times it by 180, okay? Don't worry, we'll talk through it. We'll keep these up here and we'll work through them. So now, I am looking on page 253. I've been working, wow. Oh my gosh, we are making great time. I'm on page 253 on Try These. So what I'm going to do is I'm going to fold it in half and try really hard to make sure you can see both. We're going to work through them. All right. So find the sum of the angle measures, okay? The sum of the angle measures for each polygon. So number 1, an octagon, 8 sides. Number of sides is the number of vertices. It's the number of angles, right? So I'm going to do 8 minus 2 times by 180. 8 minus 2, which is 5. Then I'm going to times it by 180. And I will find out the sum of all the angle measures. Okay, so calculator never leave me. 5 times 180 is equal to 900 degrees. So with a octagon, all of the angles added up together in an octagon equal 900 degrees. Now, number 2, a heptagon. Thank you for telling me these, book. You're so nice. 7 sides. So I'm going to do 7 minus 2. That gives me 5. Oh my gosh. You guys. I'm not redoing it. I'm already 16 minutes in. I'm losing my mind. So 5 times 180 is equal to 900. Please make sure you're better than me. That's all we're doing. So a heptagon has 900 degrees. An octagon is 6 times 180. Gosh, I hope you guys caught that. I'm definitely losing my marbles here. All right. Corin Christine, it's not going good for me. 6 times 180 is equal to 1,080 degrees. Oh, all right. I miss you all. I think you guys keep me sane. All right, well, as sane as I can be. An 11gon, so it's 11 minus 2. Let's make sure I'm doing my easy math correct. Oh, be better than me. Be better than the teacher. 9 times 180. 9 times 180 is equal to 1,620 degrees. All right, and then the last one. 15gon. Okay, so 15 minus 2 is 13 times 180, which is equal to, oh, I am embarrassed, but what are you going to do? 13 times 180. I think I'm more embarrassed about that than my singing. 2,340. All right, so just make sure that you pay attention better than I did. All right, so now find the value of the variable in each polygon. Oh yeah, this is where we get to isolate the unknown. I know that the exterior angle, let me pull that out. The exterior angles are adjacent and supplementary, meaning they equal 180. So to find out what x is, I know this. So number 5, here's my setup. 180 degrees is equal to 142 plus x. Now we get to isolate the unknown. So I'm going to subtract by 42 from one side. If I do it to one side, I do it to the other. This cancels out. My x comes down. Calculator, 180 minus 142 is equal to 38. So x is equal to 38 degrees. Beautiful. All right, we're going to keep going. Number 6. All right, so if I'm looking at number 6, here's what I'm looking at. Here's what I see. I'm going to write in my book. I see a 90 degree. I see a 90 degree. And then remember with 9, 5, that means that this angle is equal to this angle, which is equal to this angle. So 3 of them. Okay, now how many sides do I have? 1, 2, 3, 4, 5. Okay, so now I need to go find the sum of all angles first. Then I'm going to be doing some work. So if I have 5 sides, I'm going to subtract 2. Let's make sure I do my subtraction right. 5 minus 2 is 3 times it by 180. So 3 times 180. So all of these angles, the 90 plus the 90 plus this plus this plus this, equal 540. Okay, so now here we go. I've got my setup. I'm ready. 540 is equal to 90 plus 90. I could write 90 plus 90, or I'm going to write 180 plus 1, 2, 3, 3x. Now I get to isolate my unknown. Minus 180, minus 180. 540 minus 180 is equal to 360. Bring my equal sign down, bring my 3x. Now I gotta isolate, divide by 3. If I do it to one side, I do it to the other. 360 divided by 3 is equal to 120 equal to x. Okay, so when I had to find the variable, x is equal to 120 degrees. Now let me go back and check that real quick. 120 plus 120 plus 120. Why did I do that? 1, 2, 3. Plus 90 plus another 90 is equal to 540. Woohoo! I'm not losing it all entirely. All right, so number 7, what is the angle measure of each interior angle of a regular decagon, a polygon with 10 sides? Okay, so the angle measure, what is the angle measure of each interior angle of a decagon? So let me go back. A regular polygon has equal sides and equal angles. And so that, them saying right there, of a regular, so that means they're all going to be equal. Okay, number 7, a decagon. We're looking for the measures of an interior angle of a regular polygon. We got our formula right here. So we're going to do 10 minus 2 times by 180 divided by 10. Okay, that's when the calculator comes in, saves us. 10 minus 2 is equal to 8 times 180 divided by 10. So the interior angle of one angle in a regular decagon is 144 degrees.